extraction of some kind of meaning of the word prime. That is, that doctors and nurses have something to do with each other or whatever. Okay? So what Marcel tried to do here is to show that, yes, in fact, priming is not, the implicit perception, what he called subliminal perception, is not just limited to extracting the physical features of the prime. You can also perform certain kinds of semantic analyses on the prime as well. Here's another example of this. This is what's known as the subliminal Stroop effect. You all know what the Stroop effect is. People find it difficult to name the color in which a word is printed if the word is, in fact, the name of another color. That's the Stroop effect. Well, in this kind of experiment, the subject's task is, the subjects are presented with patches of color, and they're simply asked to identify what the color is, in this case, green. The trick is that there's a color word that's embedded in the patch. And that color word either is the same as the color of the patch or different from the color in the patch, a congruent word or an incongruent word. And then finally, this embedded word is either masked or not masked. And well, actually, there's always a mask, but if the stimulus onset asynchrony, the SOA is short, you don't see the word. That's the masking effect. If you delay the onset of the mask for some interval period of time, say 68 milliseconds or a second or whatever, the mask is still there, but you see the word. Clearly. Okay, so we're keeping everything the same. All conditions are constant except the interval between the onset of the prime, the word, the embedded word, and the onset of the mask. And what you can see here is that here's the Marcel experiment. What you can see here is that you get a nice Stroop effect. When the word, embedded word, is incongruent with the color, it takes longer to name the color, okay, than when the embedded word is congruent. That's the basic Stroop effect. And you get it with a long SOA where people clearly see the word, okay? But you also get it with a short SOA where they don't see the word because of the very, very, very short interval between the presentation of the word and the presentation of the mask. Over here we have the word and the color presented simultaneously. Here we have the word and the color presented with some kind of offset. You get the same basic thing. When you can see the word, you get a Stroop effect. When you can't see the word, you still get a Stroop effect. This is known as the subliminal Stroop effect. And again, it suggests, strongly indicates, in fact, that you can get semantic analysis of the word to know that the word BLUE refers to a particular color, which is different from green, okay? You can do that even though you can't actually see the word. This was an astounding result for many individuals and led a bunch of investigators to try to repeat it. You can repeat it. Here is work by Phil Miracle and his colleagues, University of Waterloo in Canada. And what they did was to vary the SOA, vary the stimulus onset asynchrony between the onset of the word and the onset of the mask. Remember, the longer the SOA, the more likely you are to see the word. The shorter the SOA, the less likely you are to see the word. So if there's no mask, you get this big Stroop effect. If the SOA permits people to detect the word 90% of the time, you still get a Stroop effect. Even down to 55% of the time, that's still a significant Stroop effect. It's small, but it's there. And then if the SOA is further shortened so that the word is detected only 25% of the time, well below threshold, the way thresholds are commonly defined, then and only then does the Stroop effect disappear. So we've got two different paradigms, and there are lots of others. Masked priming affecting lexical decisions, as in some of the Marcel experiments, and masked subliminal Stroop effects as well, showing that in fact Subliminal perception does occur, as it's defined in these kinds of experiments, and that subliminal perception does enable the extraction of meaning from the subliminal stimulus. You're getting priming that's based on a semantic or a meaning-based representation, not just priming based on a physical representation. On the basis of experiments like this, Cheeseman and Miracle made a distinction between two kinds of thresholds, what they called the subjective threshold and what they called the objective threshold. The subjective threshold they identify as a level of stimulus presentation, or the detection level, where subjects claim not to be able to discriminate the stimulus at above chance levels. This is very much like Person-Jastro's zero confidence. Okay? They call it the subjective level because you're defining the threshold, the subjective threshold, you're defining the threshold based on the subject's own conscious experience. Okay? And then there is what they call the objective threshold, which is the level of detectability below which the stimulus has no effect on behavior. Here's a nice example. Let's go back to the previous experiment for a second. Okay, here you're getting a nice substantial Stroop effect here where the prime detectability is about 90%. 90% of the subjects will detect the prime. Here you're getting closer to what Cheeseman and Miracle would call the subjective threshold. You're just barely above chance at detecting the prime here. Here you're well below the subjective threshold, probably below the objective threshold as well, and there's just no effect at all. The importance of this distinction between the subjective and objective threshold is that Cheeseman and Miracle said, yeah, there is a threshold after all, but there's not just one threshold, there are two thresholds. There's an objective threshold below which the stimulus has absolutely no effect on anything as far as behavior or experience is concerned. But there's also a subjective threshold above that somewhere, and it's in this area between the objective threshold and the subjective threshold that so-called subliminal perception effects, the subliminal perception effects occur. Okay? Yes? No, they can actually see the word. They're just asked if they can see the word in these experiments. Yeah, and again, if you can see a word like blue, you know what it means. Okay, so again, it's detectability that's at issue here. So here's how they kind of put this into practice. What you're seeing here is the effect. Again, we're looking at subliminal Stroop effects here, where the word is clearly above threshold, supra threshold. Here, where the prime, the color word, is detected only about 55% of the time, very close to the subjective threshold. Here, where the prime is not detected at all, and what you can see here is when you're close to the subjective threshold, you can still see the Stroop effect. When you're at the objective threshold, it pretty much has disappeared. And here, there's a short interval between the presentation of the prime and the target. Here, there's a somewhat longer interval between the presentation of the prime and the target. Notice with a longer interval, the Stroop effect gets bigger, and with a very long prime target SOA, the Stroop effect gets even more substantial. So again, the more you shrink the stimulus onset asynchrony, the closer you get to the objective threshold. Okay? When you make that very long, you're probably over the subjective threshold. As you shrink it, you get closer to the objective threshold. So again, just to kind of bring us back to this the point again, the prediction in these experiments, and this is a prediction that has not been tested as well as it should be, hint, hint, for those of you who are contemplating senior theses, okay? it basically follows from Cheeseman and Merkel's idea that you're going to get semantic priming in subliminal perception the closer you are to the subjective threshold, okay? And when you get down here, very close to the objective threshold, semantic priming may disappear, and all you can get is repetition priming based on a perceptual representation. That's a perfectly reasonable hypothesis that you can derive from these experiments. I know that because I asked Phil Merkel. He's an old friend. But Merkel retired before he could test it. So it's still out there, okay, for anybody who wants to do it. Okay, so these kinds of experiments establish that there is such a thing as subliminal perception, that beyond the threshold bugaboo and all of that, we can identify an interval between what Merkel calls the objective threshold, where there's no effect of the stimulus on behavior at all, and the subjective threshold above which the person sees the stimulus clearly, okay? Within that range, you can get priming effects, and not just repetition priming effects, but also semantic priming effects. So that's basically the story so far. I'll come back to this for a little bit later about the so-called subliminal perception. But subliminal perception does not exhaust the domain of implicit perception. There are other ways in which you can see something like unconscious perception. So, for example, there are conditions, there are kinds of experiments where you can get unconscious perception even with stimuli that are clearly supraliminal, presented at intensities or at SOAs between prime and target or prime and mask that clearly permit the prime to be consciously perceived, but for one reason or another, the subject does not consciously perceive a consciously perceptible prime. There are two basic conditions under which this occurs. One is certain forms of brain damage, and the second, certain attentional manipulations where the prime is presented and it's clearly detectable if the subject's looking at it, but the subject's attention is distracted from it in various kinds of ways. Let's look at the neurological cases first. Here is a very famous case. This is patient DB, a British man who was studied by Lawrence Weisskranz, who suffered an injury to a part of his primary visual cortex, area V1 in the occipital lobe, right there, which wiped out his vision in a particular portion of his visual field. Early on in his illness, the vision, the scotoma or blind spot, covered basically the whole left-hand portion of space. So he could see in the right-hand portion of space, but he couldn't see in the left-hand portion of space. Later on, he recovered some vision in his scotoma, so that he was left with a residual scotoma that covered basically the lower left-hand portion of space. Down here, he couldn't see anything. Up there, he was okay. Up there, he was okay. Down here, he was okay. But this lower left-hand portion of space, he just didn't see anything at all. Now, what Weisskranz then did was to say, all right, well, I'm going to tell you, there might be something